In this video, I'm going to be showing you how to set up and use Excel Solver for the sandwich problem. So the way we usually set up the solver problems for linear programming is we split the screen into two parts. The upper part here we are going to reserve for our inputs. So this is where we're going to put our constraints and our objective function, the numbers, the coefficients, so that we can easily proofread what's going on. Then in the lower part of the screen, we're going to do the actual constraints, the functions that we're going to put into the solver program. So let me start off with the sandwich problem. Now, what we're going to do in this particular way of setting up problems is we're going to put the decision variables in the column names. So I have club sandwiches, and I had turkey sandwiches, and I'm going to move these so that they look nice. Then I'll have the constraint, and I will have the amount on hand. I know that a lot of students like to take shortcuts and name these like X1 or XY or whatever. It really does pay to keep this organized, because at the end you will know what's going on, and two, you will have nicer output so that you'll be able to interpret your output better. So here I'm going to name the constraints. This is going to be the amount of turkey constraint, and for the amount of turkey constraint we had 3/10 of a pound. For club sandwiches, we had 6/10 of a pound for turkey sandwiches. This should be less than or equal to, so I'm going to list that as less than or equal to. And the amount on hand, we had 21 pounds. The next constraint was the amount of bacon. For the amount of bacon, we had 2/10 of a pound for the club sandwiches, nothing for the turkey sandwiches. That also was a less than or equal to, oops, wrong one, less than or equal to constraint. And for that we had 5 pounds. The third constraint we had was the amount of bread. For club sandwiches we had 1/2 a pound, that's a lot of carbs. For the turkey sandwiches we had 4/10 of a pound, again it's a less than or equal to constraint. And the amount on hand we had was 20 pounds. Now, the way this is usually set up is that, as I said, we'll put the decision variables across the top. If we have more decision variables, we just add more columns until we get to our sign constraints. So we would just be adding columns here, okay, and shifting over these two parts with the equal, less than or equal to, greater than or equal to signs, and the right-hand side of the constraints. They would just be moving over to the right. Then, at the end, I'm going to have the profit per sandwich. This is my objective function. My profit per sandwich, I'm making $3 per club sandwich, $4 per turkey sandwich, and this is not a constraint, so I have nothing in these two columns. One way to make sure that your table is more organized and you can see what's going on is you can highlight these and go and put a nice box around them so that you know that they are grouped. And that's grouped with this. So you can see what's going on and what goes with what. So the whole point of this upper part, again, as I say, is I'm just entering numbers here so I can proofread that I've got the numbers that are going to go into the actual model correct. So I'm checking against my input here against the slides that I gave you, and they are all correct. And I do not want to change the color scheme. I want to keep the color scheme and not show that message again. Sorry about that. So now we're going to go down to the model part of the linear program. And I'm again going to have the decision variables. I'm going to put them here. And I am going to, since I only have two, I'm going to label them across. I'm going to merge and center those. My decision variables are club sandwiches and turkey sandwiches. And I'm going to put values of 0, 0 in them to start. In these later versions of Excel, you have to have the 0, 0 in here to start for the values of the decision variables. Otherwise, you will get an error message. And it's very difficult to see from the error message that the only problem is that you didn't put 0, 0 there. So always put 0, 0 here. And we're going to label this amount produced. So when we're done with Solver, our optimal solutions will show up here. So they're not going to stay 0. When we're finished using Solver, these things are going to have these solutions in them. Now I'm going to have the objective function. So I'm going to say I'm going to maximize. And here I'm going to put in a formula. What we generally use for the linear constraints is called the sum product formula. And the way the sum product formula works is, what is it that I want to maximize? The objective function is I want to maximize the profit per sandwich. So I'm going to multiply these values. So I highlight that array, comma, these values. So the way this works is that I multiply this 3 times the number of club sandwiches plus 4 times the number of turkey sandwiches. And that's what the sum product is doing. You'll be using sum product, or we'll be using sum product through this whole thing. It's not sum, it's not product, it's something called sum product because it's this times this plus this times this. So you're doing the product and then summing them. Now I'm going to rewrite the constraints here. Okay, and I'm going to call this amount used. I'm going to call it the left-hand side of the constraints. I'm going to have the sign of the constraint here, and this is going to be the amount available, which is the right-hand side constraint. I'm just going to copy from here the labels there to save myself some time. Just drag that down. Okay. I'm also going to just copy these and the amounts, because the amount is just a constant. So these can stay without any further work. So I'm dragging it down to the number of constraints that I have. I have 3 constraints. Now here I'm going to be using the sum product again for the left-hand side. So I'm going to say this is equal to the sum product of my decision variables, comma, the amount of turkey here. Okay? So what this is doing, and it's saying 0 because these are 0 here, but there's a function behind it. That's very important. And I will, I'm going to change these to $signs because I want to be able to drag this and not have to retype everything. This stays constant. So that's what I just had for the $sign, B12 and C12. I want this to stay fixed while I move down these columns for the rest. So let me drag that down. Okay, so right now the reason why these are saying 0 is because these functions are 0 because I'm multiplying by 0. Let me show you how this is working. If I make this 1 and this 2, you see how these numbers here are changing. So we're going to be the solver is going to start at 0, 0, but all these things here are linked to the values of the decision variables here. Now we are ready to use Solver. So we're going to go over to Data, go to Solver. Okay. We're going to set the objective. So what is the objective? Our objective is the cell here where we said maximize. So remember, everything in our model is down in this area. So we're going to maximize B14, okay, and it's going to be a maximum, so you have a choice of minimum, by changing variable cells. So these are the decision variables. So we're going to be changing this one and this one from 0 to whatever. Okay, and I'm thinking that yes, let me close it because my 0 here disappeared when I put those other numbers in. If I don't have that 0, I am going to get an error message. Okay, so Data, Solver, and you see it's kept these things, so it wasn't a disaster for me to have closed this for a bit. So it keeps it until you reset. Okay, now subject to the constraints, I have to say that I'm adding a constraint, and I can do this. I can highlight all these, and then this is where I choose my constraints, whether they are less than or equal to, equal, greater than or equal to, and by the time I'm doing this, we've already done integer and binary. This is where you decide whether you have an integer constraint or a binary constraint, or a difference constraint, which we're not going over. So I happen to have all of them be less than or equal to, which is why I could just blithely just copy all these over, and then I'm going to copy all these over. If you don't have all the same constraint, you can't do it exactly like this, but you should group them so they have all the less than or equal together, so you can put that group in all together, the greater than or equal to's, the binaries, etc. So you can group them and not have to do them one by one. So I'm going to say OK. So I've got all my constraints there. I want the unconstrained variables, I want them to be non-negative. I want to choose the simplex LP method, simplex linear programming method. And I believe that is all that I need. I'm going to say solve. And you see it says that I found an answer. So keep the solution. Notice that when I got the solution, lo and behold, I have 20 club sandwiches and 25 turkey sandwiches, which is what we got when we did this by hand, along with a profit of $160, which is also what we got when we did this by hand. So you see, when you do the solver, once it's found a solution, it automatically puts the solutions here. Now, the next thing you want to do is look at the reports. You want to look at the answer report, the sensitivity report, and generally the limits report. So you hit OK, and then that populates tabs down here. The answer report. This tells you your objective cell, your original value. The original value we had was 0. Our final value was 160. For the variable cells, we started off with zeros for our decision variables. We ended up with 20 and 25. And notice it says that we're using continuous. It's not an integer program. Okay. And then these are the constraints. It tells us what the right-hand side is. It gives us what each of the constraints were. You see, if you don't use a nice name, you don't get these nice labels here. Okay, it tells you whether these constraints are binding or not binding, and it tells you whether or not it's a slack or not whether slack or surplus, but slack variables is 0 where it's binding, and it will tell you whether there is a slack or surplus variable, but you have to decide whether it's slack or surplus depending on the sign of your constraint. And then here is the sensitivity report, where this gives you the allowable increase and decrease for the coefficients of your objective function. And it also gives you your shadow prices and your allowable increase and decrease for your constraints. So that's it for the how to use Solver. So please try to use Solver on various problems that you have. I will upload another video with more variables so that you can see how they work, probably with binary variables. But for now, you should be able to try to use Solver, load up Solver, and try to use Solver based on these two videos.